So, at this point in our project, we have collected our requirements from the customers, which were here, and created a list of requirements, which is here, and made a classification of our requirements into functional and non-functional, and also with the verbs plus model into categories which explain what we want our system to do. So now our next task is to create the analytical architecture, the first UML designs, and later go with the BCE analysis to start doing actually something that functions as a basis for the technical implementation of our system. So at this point we have the list of requirements and list of requirements candidates. We have gathered and described our functional requirements and non-functional requirements, and we have specification for the environment that is the platform where the system is going to be working, and we know pretty much on what sort of system we are building. So, our list of requirements or requirements candidates have all the properties. We have talked with the stakeholders, we know the system features, we know the software requirements, for example, that we have in the legacy systems that we have only 640 kilobytes of conventional memory available if we are doing something really old, like museum old. And we also have the properties in cost estimates, prioritized and risk evaluated forms. So, at this point, what we actually need to do as our first step to start from our list of requirements into actually analytical system is to do the conceptual modeling. This means that we build a domain model or business model with a class diagram that describes the business concepts, all the information that we're going to save, and how different entities or concepts are going to be communicating with each other. This means that we take all the components or classes in this occasion are the different concepts that the system is doing. The attributes are the different data flows or data items we have to store, and methods and connections between classes are defined by what things have to interact with each other. So basically, we are not yet defining the final database or anything like that. But the idea is that we build a system which pretty much defines all the basic functionalities. For example, in this example, we have defined what sort of information and connections we would be having for one university course. We have course implementation, teachers, courses, announcements, course material, for example, the things you are now listening, and all the other things. It may not be very technically oriented, but it's a start. We have a domain model which more or less says that, okay, we have these sort of things here, we have these sort of connections, and we are manipulating this sort of information. So, going forward from that, we identify the actors and use cases. This means that we identify all the stakeholders or roles which are doing something. Users, customers, players, administration, or in case the actor is not an actually human, the other systems we have to connect to, like bank systems, server-side databases, or other companies' ordering system or government taxation database. The use cases, they describe how the system is used. So for each cluster of requirements, we define use case to define one major functionality of system. For example, should we be making an ATM machine, we would have use case for withdrawing money, or with seeing the activity on our account, or these sort of things. When we have the basic use cases set, we prioritize them, write their descriptions, and, for example, for user interface, create prototypes, so we have more or less identified the interface we are going to build, the actors or users that are going to use the system, and how the system is used. So, for the identification of actors and use cases, of course, we can use the domain and business model we just created, the requirements, and all the other things we need to know about the system. Of course, it is important to understand that the actor, like the salesperson here, doesn't have to be a person. All the actors are actually also the systems we connect to, and the use cases may not actually be something that's always done, but it may be something that happens within the system. For example, with the automated teller machine example, checking the PIN code or PIN number from what the user inputted may be existing as a separate use case because it happens several times in several different activities. But in fact, it may be only something that the system internally does with the bank database. It doesn't have to be always invoked by the actors themselves. So, the prioritization of use cases is the next thing we have to do. Of course, with the use cases, we also have to think about the testability. How can we assure that this thing we have defined happens exactly as we have defined it? Also, architecturally important use cases have to be defined because these are the risky use cases. If which they fail, basically everything else fails around them. If we are building a mobile game which is otherwise fine but cannot be run on our target platform because it has too little amount of memory, then we are going to be having a really huge problem. So the use case in this example would be something like load the game engine, and if the game engine loads on our target platform, we know that this is something that actually can be done. Also, the other high-risk modules like network connections and artificial intelligence and these sort of things are also ones that have to be identified so that they can be the first ones to be implemented. This has a simple reason behind it. If we can't implement one of the central modules, we already know that the project is going to fail, so it's easier to cut losses at early point than fall into the sunk cost fallacy, which means that we have already used so much money on this development that we cannot stop now. Anyway, the use case diagram is used to give a free-form description of functionality of the system, and it actually may be also divided into several diagrams. For example, use cases that are invoked by the customer, use cases that are invoked by the administration, use cases that are invoked by external auditors, and so on. The use case descriptions themselves, the written part, are started by giving a rough description how the use case happens, and later describing in detailed form how the user interface is used and how the functionalities happen. And important part here is to keep in mind that we actually have to give all the different paths that may happen during one use case. Typically, the use case flow of events follow the happy path, meaning that the customer always does everything correctly and the system functions without any problems, but also the other options like the user presses cancel, or that the user gives the wrong PIN number, or that the connection to our central server is lost during this activity, have to be documented in order that the testing people can see what should be happening when we simulate error situations, and therefore we can test that the system actually works against these sort of problems. So, what do we write in our use case description? Basically, this is a simple list of things. So, starting state. What are the preconditions for the function? The system is online, it has electricity and online connection. how the use case starts. So what we have to do, the customer has to have a bank card and they have to insert it into the card reader. In what order the use case is executed, the card is put into the reader, user puts in their PIN number and presses enter. How the use case ends, this includes all the different alternatives in addition of the happy path activities, leading into the alternative flow of events and illegal flow of events. The customer pries the card from the system during the session. So, and other things that can be defined is what actors participate in the activity, what information is exchanged, so we know what sort of test material we have to prepare, what kind of data and resources are used, and other non-functional requirements, for example for performance, response times, security and other things that are needed to ensure that the use case happens without problems. So, as a final reminder, this is one of the use case templates from the rationally unified process. It basically has the brief description, flow of events, the happy path in basic flow of events, alternative flow of events, and requirements, preconditions, and other things documented after this. So the idea is that after this activity, we have the use cases and actors and the basic functionality is nailed down so that we know how the system should be behaving, what sort of activities we can do, what connections do we have, and what user groups we have. This is something that's already much more than the basic requirements, because after this step we actually have to define the different modules and go beyond the simple domain model to create something that's technically feasible to be implemented as a developed program. And that's what the BCE analysis is actually all about.